A very good day to one and all. We are Team 5 and our project is the seed ball making machine under the guidance of our professor Ashwin R. Kubasad Gudar. Our team consists of Darshan S. Hongund, Kaushik V. Kuntanal, Adityan Matthew Mehta, Chakit Lalit Bhandari.
Here is our problem definition. To design a semi-automatic seed ball making machine able to produce 5 seed balls per minute with a volume of 5 cubic feet. The budget should not exceed Rs 4000 and should work for 2 hours continuously. Machine should indicate the user after detecting the materials and should start making the seed balls and eventually store them.
This is our function tree and functional clustering where the raw materials are added to the machine. The machine detects the raw materials, that is the clay, seed, and water. The motor starts rotating the drum with the help of a DC motor and belt. In our next function, the clay ball layers are formed where the machine rotates the clay, seed, and the water present in the drum. The rotation motion of the drum makes the clay envelop the seed, forming a protective layer. In our next function, where the prepared seed balls are stored, the seed balls formed are transported by pipe. Pipe transports the prepared seed balls to the container, and the stored seed balls are indicated by LED. And in our next picture, we have the functional clustering where the preparation of the seed balls and the formation of the clay ball layer is grouped into one cluster, and the storing of the seed balls is grouped into another cluster.
There are 3 subsystems identified in our course project. First is the seed and clay holding unit, second is the seed ball making unit, and the third is storage unit.
So these are the conceptual designs generated by our team, where the first concept is by Darshan, and the second by Kaushik, and the third by Adityan, and the fourth by Chakit. And out of these four conceptual designs, the third concept was decided and chosen by our team for our project, which was done by Aditya and Matthew Mehta. So this is our complete model constructed on Autodesk Inventor 2019. As you can see, our first subsystem consists of two hoppers which are connected to two L-shaped joints which continue to the pipes, which will transport the raw materials, that is, the clay and seeds to the drum, and this was made by Darshan. And in our next subsystem, we have the seed ball making unit, which consists of a table with like base and has four movable discs attached to the corners of the table, which support the drum on top. And this drum is rotated by a DC motor, which is housed beneath the drum and is attached to the drum by means of a belt, which helps in rotating the drum. After the seed balls are prepared due to the clockwise rotational motion of the drum, the balls move forward and fall into a tray that directs the balls to the transportation tube. And the second subsystem was made by Adityan. Now, our third and final subsystem consists of a tube and a circular container, and here an IR sensor counts the number of prepared seed balls passing through the tube and displays the number of seed balls on the LED display. And the prepared seed balls are stored in the container below. And this subsystem was made by Kaushik. So this is the circuit diagram of our entire system, which consists of three DC motors, four IR sensors, two red LEDs, one blue LED, one buzzer, one LED screen display, and an Arduino Mega 825560 circuit.
These are the set of materials required for our entire course project. A conveyor belt made of rubber sheet, a storage unit made of wood, a seed or clay container made of an acrylic sheet, a plastic barrel, a DC gate motor, a curved pipe made of plastic, a tray made of an acrylic sheet, a DC motor, an Arduino Mega microcontroller, an IR sensor, a rubber water pipe, a plastic spiral, a plastic water container, and a normal tube made of plastic. Here is how the process goes on. Initially, the DC motor is turned on and the barrel starts rotating. The IR sensor detects the seed and clay, and with the help of the DC powered spirals, the input is driven towards the drum and released into the drum. The IR sensor detects the input by glowing the LED. The jet nozzle sprays water into the drum, and when seed balls are made, they fall onto the tray and transported into the container through a tube. The IR sensor present in the tube detects the number of seed balls which is displayed on the LED screen. The process is completed and the DC motor is turned off. Here is the battery and motor sizing of the system. We require two motors of 10 rpm each. For the second subsystem, the calculations are as shown. Torque is calculated as force multiplied with the perpendicular distance. Here, the force is given as 25 kgs and perpendicular distance as 22.5 centimeters. From the formula, torque can be calculated as 562.5 kg centimeter. With the help of factor of safety, maximum torque can be calculated as 843.75 kg centimeter. An adapter of 9 volt is also required, and with that, Johnson motor of 500 rpm is required.
These are the functions of our system, and the functions are as follows. First one is to make the seed ball, and then to detect the materials, indicate that the process has been completed to the user, store the seed balls in a container, and the last is to indicate the presence of seed balls in a container. So this is our circuit diagram simulation model which was created on Tinkercad. First, we have the DC motors in our first subsystem, which is the seed control and the clay control. As you can see, once the motors start rotating, the red LED glows, indicating presence of materials and transport of raw materials to the drum. These motors control the flow of seeds and clay to the drum, and once the raw materials reaches the drum, the motor starts rotating and the seed ball control motor, as shown, controls the movement of the drum, and the blue LED glows, indicating process start. And once the prepared seed balls are transported to the container via the transportation tube, the red LED glows and the buzzer is sounded, indicating presence of prepared seed balls. Now, unfortunately, due to the lack of components on Tinkercad, such as IR sensors and LED screen, we are not able to show our complete process that we had come up with. So here is our simulation. First, the motor starts rotating, red LED glows, blue LED glows, motor starts rotating, the buzzer sounded as well as the glowing of the red LED, which indicates the presence of prepared seed balls.
Thank you very much.